Okay, we're going to talk about robustness of model and how that leads us on to making a prediction and how reliable that prediction will be. So basically, we have to understand that Ensight is using a model to create a trend line for the data. It's using a mathematical model to create a seasonal graph as well, both the additive seasonal effects, which is the average in each year, and it's modeling that and telling us what's happening. Now, the other thing that Ensight does is it uses something called Holt-Winters model for making predictions. And that model relies on a regular seasonal pattern and a regular trend line in order to make accurate predictions. So when we have a regular seasonal pattern helps make our modeling more reliable for forecasting and making predictions. So that's the criteria. And we can see here with the Arctic ice data that we have a very strong regular seasonal pattern that every year is doing exactly the same thing as every other year, basically. And so that's what we mean by a strong and regular seasonal pattern. And how reliable your model is for trend and seasonality, how well does the software Ensight model what is going on with the data, this is going to affect what it does around predictions, okay, and how reliable that is going to be. So as long as you understand, we can confidently predict that, for example, in this particular data, that March is, every month, pretty much, March, April, March, January, February, April, May, June, July. So that these 2 months here, at least, are basically peaking in every year. And we can also see that down here, that every year is pretty much doing the same thing as far as troughs around September. So we can make predictions that that's going to be happening in every year pretty much. Now, when we look at this graph around its trend and its seasonal effect, we can see that this is not a regular seasonal pattern. That although we can identify a seasonal pattern out of this mix, that's what Ensight does, we can see that every year is not doing that same thing, that we can't say that every single year this is going to be January, March is going to be the highest quarter, or that October, December is going to be the lowest quarter. We can't say that. So I can't confidently say that every year the male births will be significantly dropped from the first quarter to the second quarter. I can't say that because it's not necessarily every year just doing that. It's very irregular, and you can see that the trend is very irregular. Although it's increasing over time, there's a lot of decreases and increases and so on over time. There's a lot of irregularity to it. And so this kind of a model here means that we might not be able to make a reliable prediction based on the fact that the seasonal pattern is not regular and the trend line is not regular. Now, when we go into predictions, this is the graph for predictions. And this is the forecast output or the predictions output that Ensight will give you. And it uses a mathematical model called Holt-Winters. And again, the Holt-Winters model is a very good model for making forecasts and predictions on time series graphs, but it relies heavily on a constant trend and a regular seasonal pattern. All right, so in order to get a reliable prediction, those two things have to be true, that you have a constant trend and a regular seasonal pattern. Now, in this graph, we can see a couple of things. We can see the pink, and in the pink is our Holt-Winters prediction of what's going to happen in the future after 2012. And then we also see in here, we see a black and green thing going on with the time series. So the black is our raw data, and the green is the fitted model that Ensight creates based on the seasonal effects and the trend line. And what you want is you want your fitted model, your green, to fit and mirror on top of the black data. All right, and that will also show us, in addition to the regular seasonal pattern and the regular trend, this visual will also tell us how well the Ensight model fits the data. Now, what you don't want to see is you do not want to see a lot of gaps between the green and the black. And unfortunately, in this model, we see that. We see quite a few gaps between the model in various areas and the raw data. And the reason that that happens is that you get these random events that happen over time. So for example, in here around 2008, if this is recreational sales goods or whatever, is quite low compared to what the model predicted it would be. And why is that? Well, that could be because of the recession and because some random event in the world actually happened to cause that data not to be as high as we would expect it to be. And so the model predicts this, but the model cannot take into account random events. So what actually happened and what the model predicts is happening is quite different. Now, when you get a lot of random events like this, then you have not necessarily a good fit. And so when we go to make predictions over here, based on the model, those predictions may not be particularly reliable. We still make them. We still make the predictions. The model will still give us predictions and so on, but they may not be as reliable as we need them to be.